Hello guys, I'm going to finish up our fourth target for factoring. These are very similar to the ones we've been doing before, but what's really interesting is if you look at each one, there's something special that comes up. When that occurs, we get these really nice patterns. Do you need to memorize these patterns? No, because if you understand the other steps from earlier, you'll be good to go. So first of all, as I often do, I am going to take a look at all of these. I'm going to look at my first terms, my middle signs and my last signs. And I'm going to try to get the signs of my factors first, even though I recognize some of these are quite different. And that way, maybe I can get some of my head work out of the way with my number sense for figuring out multiples. So the first ones are plus and plus in both cases, so that works. The second one is a minus first and a plus last. So a negative times a negative is positive. And then the third one is similar to the first guy. And then if you look at this one here, you're missing a middle term. That just means, if you want to write it that way, that just means there's a 0 in the middle. So your last term is 16. And so that means we're going to have one of each sign. For this guy in the second position in the next row is a positive in the back and a negative in the middle. So one of negative and one of negative. Again, negative times negative. And the last one is very similar to the one we just did over here. So it's going to have really a 0 in the middle. You don't have to write this once you see the pattern, but it might help in the beginning. And then you're going to notice you're going to need one of each. So again, these are helping with those multiples. Remember, in your head, you kind of want to think about like reverse distributive property, which some people say FOIL. FOIL is just a mnemonic device to remember first out in last. Okay, so I'll just put that out here in case that helps you. First term, out term, in term, last term. It's just a graphic organizer. So let's go back to the top. X and X is easy for the first one. And then for 9, I can have a 9 or a 1 or a 3 and a 3. But I'm looking for that 6, so the 3's make sense. So if you notice, there's your pattern. You can even write it as this times itself. So either of these answers is good. Why is it special? Because the 3's were perfectly matching the 9 and the multiple for the 6. Now watch this one. Easy X and X for the first. Only thing for 1s is the 1. There you go. You've got that duplicate again. So what's nice is this duplication of your factor. Duplicate means to double, right? If you double your 1, you get the middle. You double your 3, you get the middle. That's why it's a nice special pattern. So here we go. We've got a X and X and a 5 and a 5. There's that duplication again. Something times itself is squared. And if you're checking your duplication, meaning double, 5 doubled is your 10. That's why these are so pretty. Now the ones on the bottom are really interesting. Especially, I'm talking about the first one here and the last one here. Let's change colors and do those in purple just to see. This is going to be X and X again. But now you got to pick numbers, one of each, to break apart the 16. It sounds like we're going to do 4 and 4. And if you take a quick look at your outer term multiple and your inner term multiple as if you were doing reverse distributive property, notice there's your 0 right there. So if you look at your answers, it's X plus 4, X minus 4. And then you can really see why that looks like such a nice pattern. I'm going to get rid of this just so you can see the clarity of it. It's just really nice and sweet. And I'm going to go clear to the last one and see how well that works. Perfect square 3x, perfect square 3x, perfect square 16, perfect square 16. 3 and 3 is 9, 4 and 4 is 16. One of each. That's so nice. Again, these are called differences of two squares. Differences of two squares, meaning perfect squares. And you just, to undo them, think of the square root. So again, square root of 16 was 4. Square root of 16, 4. Square root of 9 is 3. Now the middle ones, look at that. You got perfect squares again. But now you got 3 terms. So the difference is we don't have one of each sign. We have the same sign. So watch how this works. Perfect square, undo. 9 is a square if you undo that, meaning take the square root. You get a 3. And look at that. You have one of each. And again, you can do that duplicate. So again, these are all patterns of squares. In some cases, like the first 3 and the last one in the middle, you have a duplication where the signs are the same. But when you look at the first one here and the last one here, those are differences of 2 squares. So why are these beautiful? The perfect squares help everybody work it out.